Unit V. Tune Model Hyperparameters. Azure Machine Learning. Reading. Tune Model Hyperparameters. Learning Objectives. 1. How to configure Tune Model Hyperparameters. 2. Results of hyperparameter tuning. 3. Technical notes. 4. Next steps. This article describes how to use the Tune Model Hyperparameters component in Azure Machine Learning Designer. The goal is to determine the optimum hyperparameters for a machine learning model. The component builds and tests multiple models by using different combinations of settings. It compares metrics over all models to get the combinations of settings. The terms parameter and hyperparameter can be confusing. The model's parameters are what you set in the right pane of the component. Basically, this component performs a parameter sweep over the specified parameter settings. It learns an optimal set of hyperparameters, which might be different for each specific decision tree, dataset, or regression method. The process of finding the optimal configuration is sometimes called tuning. The component supports the following method for finding the optimum settings for a model: integrated train and tune. In this method, you configure a set of parameters to use. You then let the component iterate over multiple combinations. The component measures accuracy until it finds a best model. With most learner components, you can choose which parameters should be changed during the training process and which should remain fixed. Depending on how long you want the tuning process to run, you might decide to exhaustively test all combinations, or you might shorten the process by establishing a grid of parameter combinations and testing a randomized subset of the parameter grid. This method generates a trained model that you can save for reuse. Tip: you can do a related task. Before you start tuning, apply feature selection to determine the columns or variables that have the highest information value. How to configure Tune Model Hyperparameters. Learning the optimal hyperparameters for a machine learning model requires considerable use of pipelines. Train a model by using a parameter sweep. This section describes how to perform a basic parameter sweep, which trains a model by using the Tune Model Hyperparameters component. 1. Add the Tune Model Hyperparameters component to your pipeline in the designer. 2. Connect an untrained model to the leftmost input. Note: Tune Model Hyperparameters can only be connected to built-in machine learning algorithm components and cannot support customized model built in Create Python model. 3. Add the dataset that you want to use for training and connect it to the middle input of Tune Model Hyperparameters. Optionally, if you have a tagged dataset, you can connect it to the rightmost input port. Optional validation dataset. This lets you measure accuracy while training and tuning. 4. In the right panel of Tune Model Hyperparameters, choose a value for parameter sweeping mode. This option controls how the parameters are selected. Ideographic period. Entire grid. When you select this option, the component loops over a grid predefined by the system to try different combinations and identify the best learner. This option is useful when you don't know what the best parameter settings might be and want to try all possible combinations of values. Random sweep. When you select this option, the component will randomly select parameter values over a system-defined range. You must specify the maximum number of runs that you want the component to execute. This option is useful when you want to increase model performance by using the metrics of your choice but still conserve computing resources. 5. For label column, open the column selector to choose a single label column. 6. Choose the number of runs. Idiographic period. Maximum number of runs on random sweep. If you choose a random sweep, you can specify how many times the model should be trained by using a random combination of parameter values. 7. For ranking, choose a single metric to use for ranking the models. When you run a parameter sweep, the component calculates all applicable metrics for the model type and returns them in the sweep results report. The component uses separate metrics for regression and classification models. However, the metric that you choose determines how the models are ranked. Only the top model, as ranked by the chosen metric, is output as a trained model to use for scoring. 8. For random seed, enter an integer number as a pseudo-random number generator state used for randomly selecting parameter values over a predefined range. This parameter is only effective if parameter sweeping mode is random sweep. 9. Submit the pipeline. Results of hyperparameter tuning. When training is complete, to view the sweep results, you could either right-click the component and then select Visualize, or right-click left output port of the component to visualize. The sweep results includes all parameter sweep and accuracy metrics that apply to the model type, and the metric that you selected for ranking determines which model is considered best. To save a snapshot of the trained model, select the Outputs plus Logs tab in the right panel of the trained model component. Select the Register Dataset icon to save the model as a reusable component. Technical notes. This section contains implementation details and tips. How a parameter sweep works. When you set up a parameter sweep, you define the scope of your search. The search might use a finite number of parameters selected randomly, or it might be an exhaustive search over a parameter space that you define. Random sweep. This option trains a model by using a set number of iterations. You specify a range of values to iterate over, and the component uses a randomly chosen subset of those values. Values are chosen with replacement, meaning that numbers previously chosen at random are not removed from the pool of available numbers. So the chance of any value being selected stays the same across all passes. Entire grid. The option to use the entire grid means that every combination is tested. This option is the most thorough, but it requires the most time. Controlling the length and complexity of training. Iterating over many combinations of settings can be time-consuming, so the component provides several ways to constrain the process. Limit the number of iterations used to test a model. Limit the parameter space. Limit both the number of iterations and the parameter space. We recommend that you pipeline with the settings to determine the most efficient method of training on a particular dataset and model. Choosing an evaluation metric. At the end of testing, the model presents a report that contains the accuracy for each model so that you can review the metric results. A uniform set of metrics is used for all binary classification models. Accuracy is used for all multi-class classification models. A different set of metrics is used for regression models. However, during training, You must choose a single metric to use in ranking the models that are generated during the tuning process. You might find that the best metric varies, depending on your business problem and the cost of false positives and false negatives. Metrics used for binary classification. Accuracy is the proportion of true results to total cases. Precision is the proportion of true results to positive results. Recall is the fraction of all correct results over all results. F-score is a measure that balances precision and recall. A UC is a value that represents the area under the curve when false positives are plotted on the x-axis and true positives are plotted on the y-axis. Average log loss is the difference between two probability distributions, the true one and the one in the model. Metrics used for regression. Mean absolute error averages all the errors in the model, where error means the distance of the predicted value from the true value. It's often abbreviated as MAE. Root of mean squared error measures the average of the squares of the errors, and then takes the root of that value. It's often abbreviated as RMSE. Relative absolute error represents the error as a percentage of the true value. Relative squared error normalizes the total squared error by dividing by the total squared error of the predicted values. Coefficient of determination is a single number that indicates how well data fits a model. A value of 1 means that the model exactly matches the data. A value of 0 means that the data is random or otherwise can't be fit to the model. It's often called R-squared, R2, or R-squared. Components that don't support a parameter sweep. Almost all learners in Azure Machine Learning support cross-validation with an integrated parameter sweep, which lets you choose the parameters to pipeline with. If the learner doesn't support setting a range of values, you can still use it in cross-validation. In this case, a range of allowed values is selected for the sweep.